Good morning, everyone. So we have a revision session on Prism now. All right, I'll tell you the equations first, then we will go to the questions. Okay. First of all, what is a prism? It is an optical instrument, like a lens or a mirror. Okay. Prism is an optical instrument, like a lens or a mirror. Now, this is the cross section of a prism. All right. A prism looks like this. Now, this is the cross section of a prism. Cross section of a prism is triangular in shape, triangular. All right. This is called principal plane of the prism, principal plane. So this is called principal plane. This is refracting surface number 1, refracting surface number 2, refracting surfaces. This edge is called refracting edge. And this is base edge, and this is base surface. All right. And this angle is called angle of the prism or refracting angle. Okay, that's all the fundamental ideas. I repeat one more time. A prism's cross section is called principal plane of the prism. Principal plane of the prism. It's triangular in shape. Okay, and this angle is called angle of the prism or refracting angle. Refracting angle. Okay, and this is refracting surface number 1, refracting surface number 2. The ray enters through this and exits through the other side. Okay, this is base surface, base edge number 1, base edge number 2. All right, now I'm just shading the bottom surface as it is opaque. This is opaque. Light does not pass through it. And I'll tell you how light goes in. Look at this. This is how light ray enters the first surface. And then what? It undergoes a bending, right? It is going from a rarer medium into a denser medium. So it bends down like this towards the base, right? Because right here, I can draw the normal. I can draw the normal right here. See the normal? This is called the normal, right? Normal is making what angle? 90 degrees. Normal is making an angle of 90 degrees. Okay. And this little angle is called angle of incidence number 1. Angle of incidence number 1, I1. Okay, angle of incidence number 1. The ray enters the prism. It bends towards the base. And this angle is called R1. R1, angle of refraction number 1. Okay. And then I told you, you can draw one more normal here. You can draw one more normal here, right here. Okay. This angle is going to be called R2. And the ray will now go out of the prism this way. It's bending away. It's bending away. Right. It's bending away like this. Do not forget to draw the arrow. Okay. Draw the arrow. Right. All right. So the ray enters the prism at an angle of incidence I1 and angle of refraction is R1. It falls at the second surface at R2, and angle of emergence. Emergence means the angle at which it is coming out is I2. Okay. So that is a basic setup. All right. So what has happened to the ray? The ray has just bent towards the base like this. The ray has bent towards the base. Right. And hope you remember this. I can extend this ray like this. That is in fact what? The path. Yes, you can find the angle of deviation there. So it is in fact the path taken by the ray in the absence of the prism. If the prism were absent, the ray would have gone straight like this. Correct. The ray would have preferred a path like that. Okay. And this is called, this, you can extrapolate this as well. And this is called what? This is called angle of deviation. That angle is called angle of deviation. Okay, you can draw the angle of deviation here. This angle is called angle of deviation delta. Right. Okay, I repeat this one more time. The ray enters at an angle of incidence I1. This is the prism. Okay, the ray enters at an angle of incidence I1. It undergoes a bending. It bends towards the base. Rarer to denser towards the normal, right? And then upon falling on the second surface, it undergoes refraction for a second time. This time from denser to rarer, so it bends away, right? And you produce this ray backward, this ray backward, right there they meet. This is angle of deviation delta, correct? And we learned this already. This angle will be I1 minus R1 and this angle will be I2 minus R2. I1 minus R1 and I2 minus R2. Why? Because this angle is I1. So opposite angle is I1. Out of which this is R1. The other must be I1 minus R1. Correct. So if I draw these angles as if this is I1, the whole of this is I1, right? So if this is I1, the whole of this is I1. But one is R1, the other must be I1 minus R1. The other side is also I2 minus R2. Now I'll write down the equations. First equation you have is A is equal to R1 plus R2. R1 plus R2. We derive this in between, but this won't come in numericals, but I'm just writing down. Okay. I is equal to R1 plus R2. Second equation was delta. This equation has come in the past in numericals. I1 plus I2 minus of A. I1 plus I2 minus of A. This is the angle of deviation. I1 plus I2 minus of A. It actually comes along the derivation. I1 plus I2 minus of A. Okay. Delta is equal to I1 plus I2 minus of A. And the third equation is N is equal to sine A plus D by 2 by sine A by 2. Hope you remember this. This is the equation for a prism. Sine A plus D by 2 by sine A by 2 to find the refractive index of material of the prism. All right. And very rarely they have asked this also. N may be written as what? N may be written as C by V. Do you remember this? Velocity of light in vacuum by velocity of light in medium. All others will be given. They will ask you to find velocity of light. Understood? V. Got it? All other values will be given. Then there is something called minimum deviation. What is a minimum deviation condition? Angle of incidence should be equal to angle of emergence should be equal to I. R1 should be equal to R2 equal to R. This time you call it delta as what? Capital letter D, angle of minimum deviation. Angle of minimum deviation. Delta will no more be called delta. It's called by the name capital letter D, angle of minimum deviation. We even have a graph for this. If you remember, this is how the graph is drawn. ID curve or I delta curve. You plot this on I and D, ID curve. Look at this. I is taken on Y axis. Sorry, I is taken on X axis. Delta is taken on Y axis. Right? What kind of a graph do we have? Look at this. This is the graph we have like this. This is called I delta curve, right? And this particular line, this particular minimum, this minimum is called angle of minimum deviation. This is called angle of minimum deviation. That location is called angle of minimum deviation. So delta is taken on Y axis. Okay, right. I is taken on X axis. So that's all about the first part of prism. We'll do questions now. One more thing is there. For small angled prism, what is small angled prism if you remember? Small angled prism is a prism, whose angle, where do I write? A prism whose angle is, I'll write it somewhere here. A prism whose angle is less than 6 degrees. This is called a small angled prism. That angle of the prism is less than 6 degrees. All right, less than 6 degrees. For such a prism, we can prove that delta is equal to n minus 1 into A. In the textbook, they have simply said we can prove it, but in class, we have proved it because it was asked once in past years, previous years. Understood? All right, we can prove that angle. Check the notes for it. If I have time, I'll do it in class. Show that for a small angled prism, deviation is independent of angle of incidence. All right. So this will cover all questions from prism. We'll straight away go to the paper. Okay. I'll repeat one more time. I'm repeating for you. Okay. This is a prism's cross section. That is how the prism would look like. The cross section of a prism, triangular cross section. Okay. A ray of light enters from left side at an angle I1. It bends one time. The angle is R1. It bends one more time. This angle is R2. That angle is I2. Okay. And I produce this ray, they are meeting right here. That is called angle of deviation. Angle of deviation is what? Angle between the ray that the path that the ray wanted to travel along and the path that the ray actually traveled along. Understood? The ray wished to travel along this path, but the ray has traveled along this path, right? That angle is called angle of deviation. Understood? Deviation, the angle of deviation. Okay. And what is angle of, first equation is angle A is equal to R1 plus R2. Angle A means the angle of the prism, the apex angle, the top angle, angle of the prism or refracting angle, okay. How do you get it? R1 plus R2. What is deviation's equation? I1 plus I2 minus of A. Okay. Then third one, refractive index is given by N is equal to sine of A plus D by 2 by sine A by 2. You may have this question also. N may be written as C by V. Okay, N is equal to C by V. Refractive index is equal to velocity of light in vacuum by velocity of light in medium. All right, we learned it in the first division class. N is equal to C by V, right? So C by V may be written here. A will be given, D will be given, C will be given, you can find V. Substitute everything, that's it. Okay. Then I1, this is condition for minimum deviation. What is the condition for minimum deviation? I1 is equal to I2 is equal to I. Angle of incidence is same as angle of emergence is same as I. Okay. Then delta will be called capital letter D. R1 is equal to R2 is equal to R. Then also for small angled prism, this was done for small angled prism. Small angled prism is a prism with angle less than 6 degrees. Angle less than 6 degrees. All right. Understood this? Write this down. We'll do the questions. All of you got it? Everyone online? So let's try this as well. Deviation is independent of angle of incidence for a small angled prism. Okay. Deviation is independent of angle of incidence for a small angle prism. Check the note for it. We have done it in class. Okay. In the reader, they haven't proved it, but you have to learn it. Okay. Time permits, I'll do it. Now let's start off with question number 11. 11 I didn't do in class, but it is one of the most important questions in class 12. Many times repeated. 3 light rays, red, green, and blue, are incident on the right-angled prism ABC at face AB. Okay, the refractive indices of materials of the prism, for red color, green color, blue color are 1.39, 1.44, and 1.47. So refractive index of 3 colors are given. What are they? Red color 1.39, green color 1.44, and blue color 1.47. Trace the paths of these rays, reasoning out the difference in this behavior. So draw the figure. Let's draw the figure first. Draw the figure first. So let's draw a right-angled triangle, right-angled prism. This is a right-angled prism. All right. Right-angled prism. All right. What are the angles? This angle is 90 degrees. This angle is 45. This is also 45. It's a right-angled isosceles prism. And which all rays are coming in? Blue, green, red. I'll draw all of them. Blue, green, red. Blue is coming in like this. First is blue. Blue is coming in like this. Blue color. Blue color falls normally on this. Okay. First color to come is blue. Now then comes green. Green color is coming in like this. Then red color is also falling on it. Okay. Like I said, it is repeated so many times. There are 3 colors falling on it. Draw the figure. I'll tell you how to do this. Red, blue, green. Okay. All right. Now listen to me. If you see the last year's videos, you know I have done it by another method, but this time I'm doing it by an easier method, much easier method. Okay. Now see this. First of all, what happens to the ray that is falling normally? A ray that is falling normally will not undergo any deviation. It will go straight and fall on the second surface. Am I correct? Right. It's falling straight on the second surface. Don't do it now. Listen. So I'm going to draw the angle here. Angle of incidence. Can you tell me the angle of incidence? See the angle. This is 90 degrees, right? This is 90 degree. Then what? This is 45. This is also 45 then, right? Because inside a triangle, sum of angles must be 180. This is 90 degree. 90 plus 45 is 135. Correct. 135 plus what is 180? This is 45. Am I correct? Correct. So this angle is what? Angle of incidence is also 45. 95 minus 45, right? 90 minus 45. 90 minus 45, right? It is 45. So I know that angle of incidence is equal to what? 45 degree. Same thing happens for all the colors, right? Angle of incidence 45. What is the condition for total internal reflection? Angle of incidence must be greater than the critical angle. Okay, so angle of incidence must be greater than the critical angle. Listen to me, please. So angle of incidence is greater than the critical angle. Angle of incidence is what? 45 here, right? Should be greater than the critical angle. I take sine on both sides. Sine 45 is greater than sine C. I took sine on both sides, okay? Sine 45 is greater than sine c. What is sine 45? 1 by root 2. Sine 45 is 1 by root 2. Is greater than sine c, you know, is 1 by n. We learned it the other day, if you remember. Okay. So, root 2 is less than n. Because when you take the reciprocal, inequality symbol must be reversed. Correct? Or see this, 5 is greater than 2. Am I correct? 5 is bigger than 2, right? And take the reciprocal, 1 by 5. Take the reciprocal, 1 by 2. 1 by 5 is less than 1 by 2. Understood? So, that is a rule of inequality. When you take the reciprocal, you got inverse. You got to change the direction of inequality symbol. Got it? So, what is the condition? If n is less than root 2, n is less than root 2, that will undergo total internal reflection. Correct? N greater than root 2 will undergo TIR. N less than root 2 will undergo refraction. Am I correct? Refraction. Now, tell me the refractive indices of each color. First color was 1.39 for blue. This is 1.44, 1.47. Okay. So, tell me about blue now. Refractive index is what? 1. It's given 1.39. Refractive index of blue is given as 1.39. Is it less than or greater than root 2? Root 2 is 1.414. 1.39 or 1.414 is bigger. Red, green and blue. This other way. Red is 1.39. Sorry. So red is 1.39, right? So this is 1.39. This is 1.47, right? This is 1.39. Am I correct? Okay. So tell me, refractive indexes for first is blue. How about blue? Blue's refractive index is 1.47. 1.47 is greater than root 2, right? Greater than root 2, right? Refractive index is greater than root 2, which means it undergoes total internal reflection. So that undergoes TIR, which means that will come straight down. Total internal reflection will happen. Am I correct? Am I correct? TIR should happen for blue color. TIR should happen for blue color. See this. Blue color will undergo TIR. Blue color will come straight down like this. How about the next color? Blue color undergoes TIR. So first I have chosen blue color for TIR. Blue undergoes TIR. Then what? Next one. What about the next color? Green. Green's refractive index is what? That's 1.44. It is greater than root 2, right? Correct. 1.44 is greater than root 2, right? So that also will undergo TIR. So it will go straight, and it will go straight like this. And then what? It will come straight down like this. Okay, like this. So that will happen. That will happen in the second case as well. Okay, right. The ray will undergo total internal reflection. That ray also will undergo total internal reflection. So green also undergoes total internal reflection. Now, how about red? How about red? Tell me about red. Tell me about red's refractive index is 1.39, no? Which is less than root 2. Less than root 2 means it should undergo refraction. Refraction means what? It should go out of this. It should come straight like this, and it should come straight like this, and then it should go out of this. Go like this. It should undergo refraction instead of total internal reflection. This is exactly what they are asking. They are asking you to trace the rays of the path. Okay. And justify. We have already justified. This is how we justify it. Understood? Got it? Write this down. Right. All of you got this? Everyone online? Let's start from the beginning. Just draw the figure. Just draw the figure, then write. Let's do it together. You can write. Write this. Write this. Write this. Write this. Draw the figure. So the three rays. Write it. Right. So first ray is falling at 45 degree. Second ray is also falling at 45 degree. Even the third ray is falling at 45 degree, right? All the rays are falling at 45 degrees. Am I correct? All the rays are falling at 45 degrees. So you know the angle of incidence, right? Correct. Here you can write here I is equal to 45 degrees. Angle of incidence equal to 45 degrees. I is equal to 45 degrees. Angle of incidence equal to 45 degrees, right? Correct. So for TIR to happen, let's isolate the cases. For TIR to happen, tell me what the condition is for TIR to happen. I should be, angle of incidence should be greater than the critical angle, right? Angle of incidence should be greater than the critical angle. For TIR to happen, angle of incidence should be greater than the critical angle. Do you understand? That is a condition for TIR. Then, angle of incidence is 45. So, 45 is greater than critical angle. Okay? Then take sine on both sides. What is this? Sine 45 greater than sine C. Sine 45 is 1 by root 2 greater than sine C is 1 by n. Don't ask me where this comes from. We learned it in the last class. 1 by root 2 is greater than 1 by n. Correct. Sine 45 is greater than sine C. So 1 by root 2 is greater than 1 by n. Then what? Take the reciprocal. Root 2 is less than n. Okay. So you can write it. We can write our conclusion. For TIR, refractive index should be greater than root 2. Okay. Which all colors have refractive index greater than root 2? Blue and green. 1.47 and 1.44. Right? Root 2 is 1.414. Correct? Root 2 is 1.414. Refractive index is 1.47 for blue. Refractive index is 1.44 for green. So both of them satisfy this condition. You can write both blue and green satisfy this condition. Blue's refractive index is what? Blue's refractive index is what? 1.47. Blue's refractive index is 1. What happened? Tell me. So you can complete this. This is the condition for TIR, n greater than root 2. That condition is satisfied. So many times this question has come. Same question without change in data. All right, same question. All right. It's in fact a very tough question. Since we do it this way, it's easy. Otherwise, very difficult. N is greater than root 2. That is valid for two colors, blue and green. Both of them will undergo total internal reflection. Whereas for red, the condition is not satisfied. N is less than root 2. Correct. So it will undergo refraction that way. Okay. So you have to finish writing this. Both blue and color satisfy the condition. So undergo TIR. Undergo TIR. They undergo TIR. Red color does not undergo TIR. It undergoes refraction instead. Okay. Now moving to the question number 2. Question number 2. Can you read question number 2? The 12. Read the question, all of you. Question number 12. Read this. The refracting angle of a prism is A and refractive index of the prism is cot A by 2. Refractive index is cot A by 2. Show that angle of minimum deviation is 180 minus 2A. Refractive index is cot A by 2. Cot A by 2. Refractive index is cot A by 2. They have given that the refractive index is cot A by 2. I'll tell you how to do this. Don't do it now. You've done this in class, but I'm doing it again. So they have given that refractive index is cot of A by 2. But you know that cot is equal to, this is something you learn in class 10, which you have to know. Cot theta is equal to cos theta by sin theta. So cot A by 2 will be what? Cos A by 2 by sin A by 2. Okay. Cos by sin is called cot. Sin by cos is called tan. Cos by sin is called cot. Okay. So cot A by 2 may be written as cos A by 2 by sin A by 2. Cos A by 2 by sin A by 2. What is the question? We have to show that the angle of minimum deviation. Now, all right. Now, n may be written as what? This n may be written as sin of A plus D by 2 by sin of A by 2 is equal to cos of A by 2 by sin of A by 2. Finished. Now, tell me, this sin A by 2 gets cut with sin A by 2, right? Sin A by 2 gets cut with sin A by 2. Tell me what you got now. This is sin of, tell me, A plus D by 2 is equal to, cos may be written as sin of 90 minus A by 2, because cos theta is equal to sin 90 minus theta. These are unique questions. There is no other question of this kind, but this has come in the past. Okay. For small angles, sin may be written as, sin theta may be written as theta. That is simply A plus D by 2 is equal to, tell me what? This is 90 minus A by 2. Finished. The last step, I'll take 2 to the right hand side. A plus D is equal to, tell me what? 2 into 90, 180. 2 into A by 2. 2 into A by 2. That is A. So you get A plus D is equal to 180 minus A, or D is equal to 180 minus A. This goes to right, minus A. So that is equal to 180 minus A is minus 2A. So 180 minus 2A. Angle of minimum deviation is equal to 180 minus 2A. So I'll do this from the beginning one more time. Let's do it together. Start writing. Let's do it together. First of all, write this. I'll tell you what all things you need to know before we start. First, you write this on the margin. These things you need to know, but these are, identities you learned in class 10. Cos theta by sin theta is called cot theta. Cos theta by sin theta is called cot theta. Cos theta divided by sin theta is called cot theta. Cos theta by sin theta is equal to cot theta. That is first point. Okay. Also write cos theta as what? Sin of 90 minus theta. Sin of 90 minus theta is cos theta. First is cot theta is equal to cos theta by sin theta. Cot theta is equal to cos theta by sin theta. Then cos theta is equal to sin of 90 minus theta. Okay. 90 minus theta. No, A plus D the whole by 2. Whole by 2, Twisha. A plus D the whole by 2, not a D by 2 alone. Okay. So, first of all, write this. N is equal to, what is given? The refractive index is given as cot A by 2. The refractive index is given as cot A by 2. Okay. Refractive index is given as cot A by 2. Cot A by 2. Okay. Refractive index is cot A by 2. Now, put a replacement for N. What is the replacement for N? We have learned a formula for N. Sin of A plus D by 2 by sin of A by 2. Sin of A plus D by 2 by sin of A by 2 is equal to. What about the right side? Right side is cot. Cot is written how? Cos by sin. Cos of A by 2 by sin of A by 2. Now sin and sin are getting cut. Sin A by 2 get cut. Now I have what? Left side is sin, right side is cos. Is that acceptable? No. I need to make both sin, right? Correct. Left side is sin, right side also should be the sin. Should be sin. So I'm going to change it now. Sin of A plus D by 2 is equal to sin of, this is cos of A by 2. How do you write cos? Cos is sin 90 minus. Cos is sin 90 minus. So cos A by 2 will be what? Sin 90 minus A by 2. I'm done, finished. You do systematically, it's nothing, very easy. This is sine, this is sine. Okay. So the brackets can be compared. Okay. Sine of theta will be theta itself. Sine of theta will be theta itself. So just imagine that you are cutting sines on both sides, which you can't do practically, but still. Sine of A plus D by 2 is A plus D by 2. Sine of A by 90 minus A by 2 is 90 minus A by 2. Now this is what? I can take 2 to right hand side. A plus D is equal to 2 comes here, 2 into 190. 2 into 90, I'm cross multiplying, okay? 2 into 90, 180 minus 2 into A by 2. Cut them now. You are getting what? A plus D is equal to 180 minus A, or D is equal to 180 minus A goes to right side. So 180 minus 2A. 180 minus 2A. All of you got this? Any questions? Let's go to the 13th question. 13, 14, 15, 16, 17. All are identical. Many times asked. I did all of them in class. One of the questions will come for sure. From this paper, you will get minimum 3 marks, 5 up to 5 marks. All right. I promise. Question number 13. Read 13th question. 13th question. Can you read it? A ray of light incident on an equilateral glass prism. Equilateral prism means what? All angles are 60, 60, 60, right? Equilateral glass prism. Okay. Root 3 moves parallel to the baseline of the prism. Underline the word parallel to baseline. That happens when minimum deviation happens. Check the notes we have written. At minimum deviation, the ray passes parallel to the surface. At minimum deviation, the ray passes parallel to the surface, parallel to the base. We have written that in the notes. Minimum deviation. At minimum deviation, the ray passes parallel to the base. Okay, can you read it again? Question number 13. A ray of light incident on an equilateral glass prism. Equilateral means all angles are 60, 60, 60. Equilateral means all angles are equal. All sides are equal. Correct? Okay, 60, 60, 60. Then what? Refractive index is also given. Refractive index is root 3. Moves parallel to baseline. Find the angle of incidence for this ray. Find the angle of incidence for this ray. Tell me how to find the angle of incidence. You can have multiple methods. Whichever method you find easier, you can use it. Delta. Delta's equation is what? Or angle of minimum deviation. D is equal to what? D is equal to 2I minus of A. But D is not given. Then you can use what? What is the question? Angle of incidence, right? Okay, fine. Angle of incidence. So let us start with the only equation you know. Write it. N is equal to. There are many ways to do this. Use the method you find easy. Right. Sine of A plus B by 2 by sine of A by 2. Sine of A plus D by 2 by sine of A by 2. N is equal to sine of A plus D by 2 by sine of A by 2. So what is my intention? I need to get the angle of, can you tell me, find the angle of incidence, right? Angle of incidence, right? Okay, first I am trying to find out minimum deviation. I'll need it. Okay, put it here. What is n value? What is n value? Root 3, simple substitution. Tell me, why do you find it difficult? Sine of, what is A? 60 plus D by 2 by sine of 60 by 2. Nothing, I just substituted for all values. Because I want to find out, I'm desperately in need of D here. Then only I can find I. Okay, there can be other methods also, but still, would suggest use to this, right? N is equal to root 3 is equal to sine 60 plus D by 2 by sine 60 plus D by 2 by sine 60 by 2. Okay, what is it? So let us simplify it. Root 3 is equal to sine of 60 plus D by 2 by sine 60 by 2. Sine 60 by 2 is sine 60 by 2 is sine 30. Sine 60 by 2 is sine 30. Sine 30 is 1 by 2. Sine 30 is 1 by 2. No, you can't cut sine. Sine cannot be cut because it's a function, no? Functions can never be cut. Okay. Sine of something by sine of something, you cannot cut them. The values can be cut, but not the functions. Okay. Sine of this by sine of this. Sine of this by sine of this is what? Sine of A plus D by 2 by sine of A by 2. Cross multiply now. What do we get? Root 3 into 1 by 2 is equal to sine of 60 plus D by 2. Sine of 60 plus D by 2. So what do we get? Sine of what is equal to root 3 by 2? Sine 60 is root 3 by 2, right? So this bracket should be what? Bracket should be equal to 60. 60 plus D is equal to cross multiply 120 or D is equal to 60 degree. I got angle of minimum deviation. I'll do that part one more time. It's basic simplification. Refractive index is given by what? Sine of A plus D by 2 by sine of A by 2. Sine of A plus D by 2 by sine of A by 2. I use the conventional method here. There can be easier ways as well. Okay. Right. Sine of A plus D by 2 by sine A by 2. So n is root 3 here. N is root 3. Root 3 value is given. Sine of 60 plus D by 2 by sine of 60 by 2. So root 3 is equal to sine of 60 plus D by 2 by sine 30. On the denominator is sine 30. Sine 30 is 1 by 2. Cross multiply root 3 into 1 by 2 is sine of 60 plus D by 2. This is root 3 by 2. Sine of something is equal to root 3 by 2. Sine of something is equal to root 3 by 2. That something should be what? 60, no? Sine 60 is root 3 by 2. Correct. So look at this yellow bracket, yellow circle. That must be root 3 by 2. Since that must be 60. So what do we get now? Sine of yellow circle is equal to root 3 by 2. So sine of yellow circle is equal to root 3 by 2. Yellow circle should be 60 then. Correct. Sine 60 is root 3 by 2 is sine 60. Sine 60. Okay, so the circle should be 60. 60 plus D by 2 is equal to 60. Cross multiply. 120 is equal to 60 plus D. D is equal to 60. Now I can use the other formula to find the angle. This is the other formula you use. D is equal to 2i minus A. So 60 is equal to 2i minus 60. 120 is equal to 2i. Or I is equal to 60 degree. Angle of incidence is equal to 60 degree. All of you got this? Anybody wants it again? All of you online. First is what? Look at this. N is equal to sine of A plus D by 2 by sine A by 2. So n value is given root 3. It's equal to sine of A value is given 60. 60 plus D by 2 by 60 by 2. Sine 60 by 2 is what? Sine 30. Sine 30 is 1 by 2. Sine 30 is 1 by 2. So I'm cross multiplying now. What do I get? Root 3 into 1 by 2 is equal to sine of 60 plus D by 2. Sine what is equal to root 3 by 2? Sine 60 is equal to root 3 by 2. So in place of this bracket, you should be having 60. So 60 plus D by 2 is equal to 60. Cross multiply 2 into 60 is equal to 120. So 60 plus D is equal to 120. D is equal to 120 minus 60. That is equal to 60. Now the last one, you have to find the angle of incidence. The relation connecting angle of incidence to deviation is what? Capital D is equal to 2i minus of A. So capital D is given. It's given here 60. 2i minus of A is 60. This goes to the left side. 60 plus 60, 120 is equal to 2i. I is equal to 60 now. All of you understood this? All right. So next one, we'll do 4 questions in a sequence and take a short break, right? So next one, question number 14, 15, 16, 17 in a sequence, okay? 14th question. We did all those questions in class, but still I'll do it. 14th one, all our previous questions, previous 4 paper questions. Trace the path of the ray of light passing through the prism. The refractive index is root 2. Find the value of angle of emergence. Draw the figure. Question number 14. We are on question number 14 now. Just draw that diagram. Just draw that diagram. Right. Just draw the diagram. This angle is like 60 degrees. Okay. So this angle is 90. This angle is 60. And this is angle A. Right. So you got a ray that's coming in at 90 normal. So you have to draw this ray. In questions, they'll give this way only. Always 90 degree normal incidence. Okay. Draw the figure. You have to trace the ray. Draw the figure and then I'll do it. What is the first thing to do? in all such questions, you have to extend this ray into the second medium, right? So let's keep drawing it until here, right? Okay, it falls normally, right? For normal incidence, there is no bending, right? All of you understood this? Okay, let's mark the angles now. This is 90 degree. All right. This is what now? This is 60. So this must be 30, right? Why 30? Inside a triangle, sum of angles must be 180. This is already 90. This is already 60. 90 plus 60, 150. Then this must be 30. Correct? 30. Then what? Tell me, this is already 90. 90 and 30, 120. This must be 60 then. 60 then. I'll draw the normal here. And I'll mark this angle as 30, which is my angle of incidence, right? Correct. That angle is called angle of incidence. Did you understand how I got it? I'll do it again. Listen, this is 90 degree. This is 60 degrees, right? 90 plus 60, 150. And this is 30 by that geometry then, right? If that is 30, this is 90, 30 and 90, 120. 30 and 90, 120. All right. 120, then this must be 60 now, because inside this triangle sum of angles must be 180. If this is 60, tell me about the next one, Halima. This is 90 already, normal. One is 60, the other must be 30, right? Correct. So I know that the angle of incidence is 30. Keep that in mind. Let's find the critical angle. Okay. How to find the critical angle? Sin C. Write it. Sin C is equal to 1 by n. The only relation for critical angle is sin C is equal to 1 by n. Correct? I just want to check if TAR happens or not. That is my intention. Understood? Sin C is equal to 1 by n. Write it. Sin C is equal to 1 by n is given in the question root 2. Correct? 45 degrees. Yes. So C is equal to 45 degrees. All right. Angle of incidence is what? Angle of incidence is 30 degrees. So which is bigger? 45 or 30 is bigger number? 45, no? So I can say angle of incidence is less than the critical angle. Correct? Angle of incidence is only 30. Critical angle is 45. Who is bigger? Critical angle is bigger. Okay, angle of incidence is less than critical angle. Greater than critical angle, TAR will happen. Correct? Less than critical angle, refraction happens. Right? Refraction happens. Write it. Refraction happens. So keep drawing this like this. Refraction happens like this. So the ray will bend away like this. Otherwise, the ray would have gone into the same question may be asked with the TAR happening also. Then you will draw it this way. All right, TAR. Okay. Now just mark this angle as angle of emergence or something, E. All right. They're asking you to find that angle of emergence now. Let's make it quick. So write angle of incidence. How do you take it? Refractive index. How do you apply Snell's law? I have said so many times, never take sin I by sin R. Just write sin by sin, denser medium angle in the denominator, rarer medium angle in the numerator, denser denominator, D. Denser denominator. Who out of these is denser medium angle? 30. Correct. Out of E and 30, 30 is the denser medium angle. That should go on denominator. Right? And E is on numerator. So cross multiply. Sin E is equal to n into sin 30. So n value is what? N value is given root 2. Root 2 into sin 30 is 1 by 2. Sin E is equal to 1 by root 2. So E is equal to 45 degrees. E is equal to 45 degrees. Angle of emergence is 45 degrees. All of you online understood this? Okay, right. So moving to question number 15. Right, 15th question now. 15th one. Draw the figure. Draw the figure. All of you draw the figure. I've taken these questions are asked so many times. I've retained only the unique ones. Okay, right. So draw this figure. We have to draw the figure like this. It's a right angled isosceles triangle. So this is like right angle. This is 45. This is also 45. N part, N is what? Refractive index is given by sin I by sin R. Sin I by sin R. But sin of which angle should be on denominator? Denser medium angle is on denominator. Denser medium angle is 30. Rarer medium angle is E. So 30 should be on denominator, E should be on numerator. So N cross multiply, sin E is equal to N into sin 30. So sin E is N is root 2 into 1 by 2. That is 1 by root 2. So sin E is 1 by root 2 means E is equal to 45. Clear, Trisha? Or tell me where you are confused, I can clear it. Hope it's clear now. N is equal to, that is how we apply Snell's law. Snell's law is N is equal to sine of rarer medium by sine of denser medium. Under the assumption that you are taking denser medium's refractive index. Okay, hope it's clear. Okay, draw the figure now. This is what? And then we have a ray that's coming in. The ray that's coming in like this. The ray is coming in like this. Okay, it's coming in at 90 degrees, right? All right. So mark the angles. Then what is the first thing to do? The ray goes straight in like this, right? Am I correct? The ray hits the surface, okay? Right there, draw the normal as always. Draw the normal. How about the angle? Angle of incidence. Go back for a minute. Just a minute. Okay. No problem. Right. So tell me what? Can you tell me the angle of incidence? This is 90 degree. This is 90 degree. This is 90, 45. This must be 45. So this must be 45, right? Angle of incidence is equal to 45 degree. Critical angle is 42 degrees. Is that given? Or 40? If not given, you can take it as 42 because glass it is 42. Okay. The angle of incidence is greater than critical angle. So TIR would happen, right? TIR happens. Okay. So right here, TIR would happen. TIR would happen. Okay. So right there also, I'll draw a normal. I'll draw the normal here. Tell me the angles. I can mark further angles. This angle is 45 degree, right? Angle of incidence is equal to angle of reflection. That's called law of reflection. Angle of incidence equal to angle of reflection. If that is 45, next is also 45. Correct. Why? Because this is 90 now. Right. Now this is 45, this is 90, this is 45. Again, the angle of incidence is what? It's again 45 here. Look at that. All the further angles are 45. Look at that. This is 45. Why is the next one 45? Angle of incidence is equal to angle of reflection. Law of reflection. If this is 45, this is 90. 45 minus 90 minus 45, this is 45. If that is 45, this is already 90, this will be 45. Correct. If that is 45, next angle will be 45. Again, angle of incidence equal to 45. Critical angle is equal to 40. TIR happens one more time. Am I correct? Am I correct? TR would happen one more time. Look at that. The ray will go back like this. The ray will go back like this. The ray will go back along the path through which it came, 180 degree deviation. All of you got this? You have to do difficult questions as well. Question number 16. Draw a right angle prism is shown in the figure. Given that the prism is made of glass with a critical angle 40, trace the path of the ray incident. Draw the figure again. Same. 18th question. Sorry, 16th question. 16th question. Draw the figure again. We have the prism. It's again a right angled isosceles prism. Right angled isosceles prism. Like we've been seeing. Okay, so the ray is coming in at this angle. You know what happens here. The ray is coming in normally like this. We have done the different color question here, no? Do you remember? Angles, let's mark the angles. This is 90 degree. This is 45. This is also 45. What would happen to the ray? The ray will go straight. The ray will go straight and hit the second surface, okay? The ray will go straight and hit the second surface. All are done by the same method. So mark the angles. This is 90. This is 45 then. Correct? If this is 90, this is 45. The third angle must be 45. So this angle is also 45. Angle of incidence. This is in fact the angle of incidence. So you can say angle of incidence equal to 45. Critical angle is equal to 40. Angle of incidence is greater than critical angle. TAR happens. Yes. TAR happens. Okay. So the ray will come straight down like this. The ray will come straight downwards like this. Instead of going out on the other side, the ray will come down. So the ray has been turned through an angle of 90 degrees. Got it? Now the next one, 17th one, we'll take a short break after 17th one. All of you got this? Everyone online? 17th one. 18, 19 are respectively from 2023 and 2024 papers. Okay, 18 and 19. All right. Hope you got it. Now 18th one. Draw the figure. Oh, 17th one. It's question number 17. We will do it and take a break. 17th one. Draw an equilateral triangle this time. This is equilateral prism. Okay. An equilateral prism. Now what's the ray doing? The ray is coming in from this side. Okay. The ray is coming in from this side. And you know what happens? It's going straight, right? Am I correct? The ray is going in like this. It's hitting the surface like this. Okay. The ray will go straight. Am I correct? Correct. The ray will not bend at the first boundary because it is falling normally on this. All right. It's an equilateral prism. So this is 60. This is 90. What does it make? All angles are 60, 60, 60, right? Equilateral prism. 60 plus 90, 150, which would make this angle equal to 30, right? So let's draw the normal right over there. Draw the normal. Draw the normal. This is the normal, okay? If that angle is 30, this angle must be 60. Angle of incidence. This is in fact angle of incidence. Angle of incidence equal to 60. Got it? Okay. So angle of incidence is equal to 60. Critical angle is equal to 40. Is it given? No. So it is glass 42. Take it as 42. Generally for glass 42. Okay. There can be special glasses for which can be 40 as well. So angle of incidence is greater than the critical angle. So you know what? You know that TAR would happen. TAR happens. The ray would go straight downwards. I'll tell you why it is going straight down. It is my intuition, but still I'll prove it mathematically. I just assume that it's going down. It's going down. So let's see if my assumption was correct. Okay, what is this angle? 60, right? What is this angle? 90. So you expect this angle to be what? 30. Let's see if we are getting it. Okay. This angle is 60, right? This is 90, right? 60 plus 90, 150, right? Then in this triangle, the third angle must be 30 degree. So you want this angle to be 30. Let's see if it is correct. This is 60. What about this angle now? 60, because angle of incidence equal to angle of reflection. Correct. This is already 90, out of which one is 60. So the next angle must be what? 30. Absolutely spot on. That is what I got earlier also. Correct? So the graph should be, the figure should be, the ray should be going straight down like this. All of you got this? Everyone online? This angle is 60. So by the law of reflection, next angle is also 60. Correct? So this is 90 degrees. So this is 60 means that would be 30 degrees, right? If that is 30 degree, this is already 60, this is 90. So that should go straight downwards, right? So just draw the graph figure for 17th one. We'll take a break. 18th one. 18th one. Just draw that figure. 18th one. We have a right triangle. We have a right triangle like this. Is it isosceles? Ah, yes, isosceles. 45. Right triangle like this. And underneath we have like another triangle, another prism. Draw the angles as well. This is 45 degrees. And this is 60. Which makes this angle also 60. Keep that in mind. I don't want to make my figure look cluttered. Okay. So the ray is coming in, the ray is hitting the surface like this. So let's keep it there and draw the normal as well. Okay, I'll come back and do it after break. Okay, now it's very easy. Now see this. Now what is the angle here? This angle is 90 degrees. Look at this. This angle is 90 degree. Now 90 plus 45, 135. This will be what then? 45, right? If that is 45, we've been doing so for so long now. This is also 45, right? So angle of incidence is what? Don't do it now. Angle of incidence is equal to 45 degree. Critical angle is 42 degrees. 41.1 degrees. So angle of incidence is greater than the critical angle. TAR happens, right? TAR happens. Draw this. Write this until here. Draw this. So TAR would happen. The ray would come straight down and fall on this. In fact, you need to draw a very big figure diagram. Otherwise, it will be complicated. Right. So draw this. It's coming straight down to the surface. Where I draw one more normal. Draw the normal there. Draw the normal there, okay? Okay. There also I've drawn the normal. The ray has just come straight down, all right? Straight down to this. Now, let us mark this angle. Can you tell me this angle? This angle is 90, correct? 60 plus 90, 150. This angle will be what then? 30 degrees, right? Am I correct? Correct. So this angle also, this angle will be what now? 60. Okay. Because this is 90. This is 30. Next is 60, right? All right. Now what? Again, this is angle of incidence, right? Angle of incidence is 60. Am I correct? Am I correct or not? Angle of incidence is 60. So angle of incidence is 60 this time. Critical angle is again 41.1. 40? 45. Okay. 45. So angle of incidence is again greater than critical angle. TAR happens, right? If TAR doesn't happen, the ray will come out of this. All right. Refraction would happen. So here TAR happens. So I'm going to draw the figure. The TAR would be drawn this way. So draw it this way. Draw it this way. It's going out like this. I'll tell you why it is going normally. Draw it this way. So this is falling straight down. This angle is 30. Next angle is 60. Why is it 60? Because this is normal, right? Normal, right? See this angle. I'll do that part one more time. So tell me what. Look at this. The ray is falling at, I'll start from here. The ray is, this angle is 60. This is 90. 60 plus 90, 150. If this is 150, 150, the next angle must be what? The next angle must be 30. Yes, exactly. This is 30. So how about the next angle? If this is 30, tell me, Dolly. This is 30. Next angle will be what? This will be 60. And that is, in fact, the angle of incidence, right? Angle of incidence is 60, which is greater than the critical angle. Total internal reflection should happen. So draw the ray this way. TIR is happening. Draw the ray this way. I'll tell you why it is so. Draw the ray this way. It's going out like this. It's going out like this. Okay, it's going out like this. Because, look at this, I'll tell you. If this angle is 60, what about this angle? Tell me, angle of law of reflection. Angle of incidence must be equal to angle of reflection. All right. All right. If that is 60, what about the next one? What about the next one? This angle will be 30, right? Because this is 90 now. One is 60, the next must be 30, right? If that is 30, this is already 60 degrees. This is already 60 degrees. 30 plus 60, 90. Then the third angle must be 90, right? I'll make it bigger. The figure is bigger now. Look at that. See this? This angle is what now? This angle is 60. This will be what now? 30. And this is already 60, right? 30 plus 60, 90. Then this must be what then? 90. Right? I was just telling you why it went normal to the surface. All right. Got it. So I repeat that point one more time. It's coming down like this. It's coming down at 30. This is 60. By law of reflection, next angle is also 60. Law of reflection, angle of incidence must be equal to angle of reflection. Angle of incidence must be equal to angle of reflection. That is 60. This is already 90 degrees. If that is 60, next one must be 30. Now, in this triangle, if this is 30, this is already 60 given in the figure. 30 plus 60, 90. Third must be 180 degree then. 180 degrees then. All of you understood this, everyone? Right. So that is how I did it. Look at this. Right. So the ray just goes out normal to the surface. All of you got it? Everyone online? So this is what it is. The ray is going in like this. It undergoes TIR first time. It comes straight down. It undergoes one more TIR. It comes out of this. That's it. All right. Okay. Now, next one, question number 19. Sorry, question number 19. Now, 19 and 20 are the same thing. I'll just give you the hint for this. You try this at home. Then I'll do it in the next class. Okay. Question number 19. Can you draw the figure, please? Question number 19. Draw the figure. We have like a glass slab. This is a glass slab, it seems. Now, next is like water slab. Glass slab, water slab. The next is a right angle triangle prism. Right triangle prism like this. That angle is like 60 degrees. Mark all the values there. First is like figure shows a water column. This is water column, okay? And A, B, C, D. It was a 3-mark question. D, E, F. This is G. This angle is given as 60 degrees. This is 90 degrees. And there is a normal they have given here. Normal they have given drawn over here. Right up to this, there is a ray of light going in. It's going in at an angle of 30 degrees. Draw the figure. I'll just give you the hint for this. 30 degrees. The ray is going in at an angle of 30 degrees. 19 and 20 are together. Same question, that number 20 is not there. So what all things are given? The figure shows, can you tell me when you finish this? The figure shows a water column BCFE surrounded by two media, 1 and 3 of refractive index √2. So medium 1 has a refractive index of √2. This has a medium refractive index of √2. Look at that. Refractive index is √2. Even medium 3 has refractive index √2. All right. Okay. Medium 1 has refractive index √2. Medium 3 has refractive index √2. In between there is what? Water of refractive index. Okay, it is not given. Anyway, a ray of light from a point source is incident on the surface B at an angle of 30. Trace the path of the ray through media 2 and 3 as it emerges out of phase CG. Okay, I'll do this. First of all, I'll tell you, look at this, what's happening to this ray? Can you tell me what's happening to this ray? This is √2. √2 is what? 1.414. Correct. This is water, which is what? 1.33. Right. This is 1.44. This is 1.33. So denser to rarer. 1.44 or 1.33 is bigger. 1.44 is bigger. Correct. So denser to rarer. So it should bend away from the normal. So it's bending away like this, slightly bending away. Right there, I'll draw one more normal. See the normal there? That is a normal I'm drawing there. Okay. All right. Now see this. I'll tell you. If I take now after this, I'll just draw the ray like this. Let me see if my prediction is correct. Okay, I'm just drawing the ray this way. Now let us see if it is correct. Look at this one. First of all, this angle R and this angle R are equal. Tell me why. They are alternate angles, right? Correct. Alternate angles. Am I correct? If this angle is equal to this angle, I would argue that this angle is also 30. Why? Angle of refraction is same. So angle of incidence also should be same because refractive index is the same, right? Medium 1's refractive index is what? √2. Oh no, medium 1's refractive index is what? √2. Medium 1. Medium 3's refractive index is what? That is also √2. Am I correct? That's given in the question. Medium 1's refractive index is √2. Medium 3's refractive index is also √2. Correct. Medium 1's one angle is R. Medium 3's one angle is also R. So the other angle is 30 means the other angle has to be 30, right? Sin I by sin R is equal to N, right? If N is the same, I is the same, R must be the same now. Correct. So that angle is 30, which means what? This angle must be 60 because this is 90 now. All right. If that is 90, this is 30, this is 60. What about this angle? This is given as 60. This is already 30. So 60 plus 30. 60 plus 30. So this must be 90, right? That is why the ray goes normally to the surface. I said normally in the beginning, right? The ray is going out normally. I was justifying why it is going out normally. I'll do that part one more time. Don't worry. See this. First of all, this is how I start off. First of all, I don't take all these things. Okay. So this is what I have right now. All right. What I have right now. Listen to me properly one more time. You will understand. Right. First of all, the ray is going in like this. Okay. It is going from which medium to which medium? Refractive index here is √2. Refractive index here is what? 1.33. So it's like denser to rarer medium. It's going from a denser medium into a rarer medium because refractive index here is √2, which is 1.44. Correct. Here it is 1.33. Which is bigger? Value water you have learned by heart. Okay. What water refractive you have learned by heart. I had said that before. Right. 1.4 by 3 or 1.33. So this is bigger than this. So this is denser medium. That is rarer medium. So denser to rarer bends away from the normal. So it's bending away like this. It's bending away like this. Away. All right. Also on the second surface. So let's draw further now. I'll just draw the normal. This is the normal on the second surface, okay? Right. So now if this angle is 90 degree, this is 60 degree, 90 plus 60, 150. What is this now? That must be 30. That must be 30 because inside this triangle, sum of angles must be 180. So this is 90, this is 60, 90 plus 60, 150. That little angle should be 30 degrees, 30 degrees. All right, 30 degrees. Now I put my argument here. Look at this. Here the angle is, this angle is R, then this angle is also R. Why? Because this line and this line are parallel. This one cuts both. They are alternate angles. Am I correct? Correct. Tell me what, Alia? This angle is 30. So one angle is R, the other angle is also R. The angle of incidence is 30. By simple logic, I could argue that the angle here is also 30. I'll tell you my argument now. This angle is also 30. Why? Because this angle is also 30. Why is it so? Because as you can see, one of the angles is R, one of the angles is R. Refractive index here is same as refractive index here. Correct? It's water glass boundary. Root 2 1.33, root 2 1.33, same conditions, right? Refractive indices are same. Angles of refraction are same. The angles of incidence also must be naturally same. Automatically same, right? N is equal to sin I by sin R. N is the same. I is the same. Then R must be the same. Or R is the same. I must be the same. As simple as that. So this is 30 degrees. How about the next one now? This is 90. So if this is 30, next must be 60. 90, 60 plus 30, 90, right? 90. Then the third angle must be what? 90, 180, no? That is going straight. All of you understood? This is the toughest question ever asked on this topic till date. It was asked in 2024. All right. Most of the students would not have gotten this, but still, it is not as difficult as it looks. If you got the idea, it's easy. Understood this? All of you got this? Shall we wind up for the day?